In order to understand hybridization, you need to first understand what hybrid orbital really mean. For instance, for an sp3 hybrid orbital, it's made up of one s orbital and a 3p orbital. Therefore, there are totally 4 hybrid orbitals over there. And for an sp2 hybrid orbital, it's composed of one s and 2 p orbitals, totally 3 orbitals. And of course, for sp hybrid orbital, which is made up of one s orbital and one p orbital, and together they made 2 orbitals. So after you understand that, we could look at leverquin, which is an antibiotics, and we can look at some of the atoms on leverquin to identify hybridization of the atoms. As beginner, if you feel more comfortable, and once you look at this line angle formula, feel free to add up all the hydrogens. For instance, for this terminal carbon, there are actually 3 hydrogens bound to the terminal carbon. Feel free to add that all up. Once you add that up, notice that on this particular carbon, it forms 4 sigma bond, and it has to use sp3 hybrid orbital to form this 4 sigma bond. Okay, so generally speaking, your sigma bonds and the lone pair would occupy the hybrid orbital. Under these circumstances, this carbon has 4 sigma bond, therefore this carbon adopts sp3 hybridization. And looking at this carbon over here, and again, feel free to add an hydrogen and to make you more comfortable. And for this carbon, it forms 3 sigma bonds and a pi bond. Under that circumstances, this carbon would adopt sp2 hybridization, and each of the hybrid orbital is used to form sigma bond. There's an extra p orbital that's used to form the pi bond. And we could also identify hybridization on heteroatoms, atoms other than atoms other than hydrogen or carbon. For instance, for this nitrogen, and again, if you feel more comfortable, and you really should, add the lone pair. Okay, so this nitrogen forms 3 sigma bond and a lone pair, and also has a lone pair. The lone pair, in general, at this stage, occupies hybrid orbital. That being said, this nitrogen would also adopt sp3 hybridization with 3 sigma bonds and a lone pair. And looking at the oxygen over here, this oxygen, which is double bonded with a carbon, also has 2 pairs of non-bonding electrons. And therefore, this oxygen has to adopt sp2 hybridization with the sigma bond orbital and the 2 lone pair, each occupying sp2 hybrid orbital. And the p orbital, which is perpendicular to the sigma framework, would be used to form the side-by-side pi bond. And for a random molecule like this, okay, this is some kind of nitrile compound, okay, over here the carbon adopts sp hybridization because the carbon has 2 sigma bonds, okay. A nitrogen over here, which has 1 sigma bond and a lone pair, also adopt sp hybridization, and with the lone pair occupying sp hybrid orbital, and there will be 2 pairs of p orbitals that's perpendicular to the sigma framework that is used to form the pi bonds. Hopefully, this would give you a better understanding about how to assign hybridization for atoms in an organic structure.